plus b squared. You see, so this is just going to be the root of a squared plus b squared. Now this is how we're going to be looking at the modulus, right? Now when we come to the argument, we are going to say that theta is equals to arg of z, which will be, and let me do this. Yeah, theta will be equal to the arg of z, which in this case, this is just going to be, we're just gonna be looking at some of the formulas, right? In this case, we have a default formula which is going to say that this is the arc of B over A. If it's in first quadrant and fourth quadrant, this is what we'll be looking at, the argument, right? In the first and the fourth quadrant. You see, right? Yeah, the first and the fourth quadrant. So when we're going to be looking at the first and fourth quadrant, this is the formula that we'll be dealing with. You see, right? And then the second quadrant and the third quadrant, we're going to be talking about it. We're going to be looking at the diagram to say this is how we define this is how we find the angle if we're in the fourth quadrant or third quadrant, or if we're in the x-axis or the y-axis, right? Now we say now that since z was given to us like this, when we come and say now the thing which we need to define next is let me say the modulus. Since already we know what is the modulus, we can say let's now define the modulus argument form. Or let me just say form, which is the polar form, right? Yeah, which is the polar form. Now, when we look at this, we are going to say that the modulus argument form or the polar form is the same thing as having z equals to, we say r, or we say this, we say z equals to a plus ib is equals to r cos of theta plus I sine of theta. I'm sure you see this, right? And then this will just be our modulus, the modulus argument form. But in some cases, you'll find that they're going to be writing it like this, where they're going to say, first, every time we're looking for this, we're going to be looking at the pair. First, we'll look at the pair, right? We say that z will be equal to that, and the pair can be written in this format, which can also be written in this format, cos of theta plus I sine of theta. I'm sure we see this. So now, what does this tell us? This tells us that A is equal to R cos of theta and B is equal to R sine of theta. This is what this tells us, right? Now, this is what we're getting from this. If I was to come and substitute my A to be R cos of theta, my B to be R sine of theta, at the end I was going to get this solution. So now we say this, that since we now know the modulus argument form and we know the modulus, we know the argument. Now let's say we are told to find the angle, right? You need to always know the region which your angle is bounded by, right? Sometimes they want you to find the angle that is between 0 and 2 pi. This one does not include any negative values, so you should always confirm this, right? So in this case, our angle here, it's going to be between negative pi and pi. That's how this is going to be. In our level, this is how in your level, this is how the angle is going to be, right, defined under. So this is the kind of a topic where things sometimes they change, right? You'll go somewhere, that's why you have two different solutions for the argument. So you need to know where does it lie, what is our restriction, because you can go to YouTube, you find that the person that you're looking at, the restriction is 0 to 2 pi. So you should always make sure you know the restriction that you're dealing with. So in this case, it means that we are allowed to have negative angles. This is what they're saying here. We are allowed to have negative angles, right? So now we're going to say that the argument, remember when we came to the argument, we said that this argument, in this case, I can also tell you that this can also be written as the argument of A plus IB, which is equal to arctan B over A. Remember, this is Z, right? So don't be shocked when you come across such things. And we should know that A cannot be equal to 0. The moment A becomes a 0, I'll tell you how do you find the argument. But you cannot use this format of tan. You see, right? Now, we are going to say this. We are going to say, I think now we just need to go back to this slide. Then we look at the questions that we have. Then we find the argument and the modulus. Then we put it in the polar form. So what we have from here, they say that we should find the modulus and argument of the following complex numbers and hence express each z in the modulus argument form. So A, we have 1 plus I, 1 minus I. So let's look at A and B. So we're going to put this in polar form. We have z is equal to 1, it was 1 plus I. So we look at this, right? They give us this. They say we should find, let's say they just tell us, they say maybe express this in polar form. You say, right? So the aim is to express this in polar form. So first thing that you do here when you want to express this in polar form, you have to define the pair. You tell us what pair is this. After telling us what pair is this, you tell us what quadrant is in. You say, right? So here's what you're going to do. First, you're going to say that Z has, or Z, let's just say Z has, then you put the pair. Our A in this case, or has ordered pair. Our pair, our A is 1, our B is 1. You see right there. So Z has ordered pair 1, 1. So, and this ordered pair, where does it lie? You see right there. So you're going to say, or you can say which, or you can say and it is in, or let's see, let's use this. We can say and it is, and we're going to say and it is in there. Let's check. Want to know what quadrant is this in, right? Now for us to know what quadrant this is in, we're going to go and discuss about quadrants. So let's cut this off for now. When you come to look at the quadrants, so I'm just gonna draw the quadrant, right? It's not that difficult, it's very simple. So we must know this, that we have 0 over let me say 0 pi over 2, which this one gives us a 0, right? And then 1 pi over 2, which just gives us pi over 2. So I'm just showing you how to find the angles. How do you know these angles like this? Then here we have 2 pi over 2, which just gives us pi. So here we know that we have 180. You know that the distance from here to here it's 108, and pi is 118 degrees. The distance from here to here, it's 90, and pi over 2, it's still 90. When we come here, we're going to use 3 pi over 2. All right. Now, we should know that this is B, the imaginary plane. This is A, the real plane, right? Now, this is positive. Positive. It means that if A and B are positive, it means that our Z will lie in the first quadrant. If B is positive and A is negative, it means that our Z will lie in the second quadrant. Then if they are all negative, it means that our Z is going to lie in the third quadrant. Then if B is negative and A is positive, it's going to lie in the fourth quadrant, right? Now, the formula here, here's what you must know here. The formula for this one here is that we can say, here they are all positive. Okay, let me start by saying this. Here, tan, sine, cos are all positive, and the formula is arctan B over A, right? Here, cos is positive, and the formula is the same as the one in first quadrant. Then we say here sine is positive, meaning that if sine is positive, it means that the rest are negative, right? Then the formula is arctan B over A. You say, right? And then the question from here is, now between the second quadrant and third quadrant, this is where you put some manipulations. You say, right, ne, to the formula. In the second quadrant, we are going to add pi as long as the restriction for our angle is between negative pi and pi. You said, as long as our restriction here for the angle is between negative pi and pi. But if it was between 0 and 2 pi, here we're going to subtract pi, and here we're going to add it. You said it, but since this one is also including the negative parts, so we're just going to keep it like this. In the second quadrant, you're going to add. The third quadrant, you subtract. You say, right? Now, we're going to say this. You should know this. When A is positive and B is 0, we're going to have our angle being 0. You see, right? If A is positive, so let me just write them here. Just gonna include some of the things here. If A is greater than 0, then you're no longer sharing your screen. Guys, let's not share our screens, right? So I think someone shared their screen, then I got knocked out on my side. Can you guys see my screen? So I say that if A is greater than 0 and B is 0, it means that our angle is going to be 0. You see, right now? Then if B is greater than 0 and A is 0, our angle is going to be pi over 2. So we'll say this if we come across questions like that, right? Then here B is going to be less than 0, A is going to be 0. The angle will be this. Then here A is going to be less than 0 and B is going to be equals to 0. Right. Now let's go back to that question. We're just gonna be referring back to this. It's good that if you practice this and know it by heart, you'll be good to go, right? So let's look at this question. We see that Z has the ordered pair. Our ordered pair is 1, 1, and it is in there. Let's check both. What we check here is, are they both positive? or we check the signs, right? Since they're both positive, we know that this is going to be in the first quadrant. If we go back and check, this is where they're both positive. You see, right? So we're going to say that Z is in the first quadrant. So this is going to be in the first quadrant. So we know now. You see, right now? Now, since we know that Z is in the first quadrant and our ordered pair is 1, 1, we can find the modulus. So it means that the modulus of Z, which is R, is going to be equal to the root of 1 squared plus 1 squared, which this is just going to be the root of 2. You see, right? Now we come and find the angle. This is just going to be the arc of Z, which is equal to arctan. It's in first quadrant, so first quadrant we use this formula 1 over 1. And here arctan 1 is just going to give us pi over 4. Now it happens that, let's say, remember we can still do this without the calculator, right? We can say that we have sine, cos, then sine over cos is tan. And then this is let's say this is the angle. No, let me call this one the angle. This one is degrees, right? So this is 0, 0, and then sine of 0 is going to be 0, cos of 0 is going to be 1, 0 divided by 1 is 0. And then second one here, we're going to have pi over 6. And then usually pi over 6 is like 30. So if we check 180 divided by 30, we get 180 divided by 6, we get 30, right? And then we say that sine of pi over, guys, can I please make this, guys? Yeah, so as I was saying, so now we know the formula here, right? Let's say you want to do this without a calculator, right? You're just going to say the root of 1 over 2. Here it's like the root of 0, this one, you say, right? Over 2, which is just going to give us 1 over 2. And then let me just do this one first. Then here it's pi over 4. You skip 5, right? You come and say that this is going to be 45. And then you're going to have root of 2 over 2. And then you come to pi over 3. Then you end at pi over 2. Alright. And then this one is going to be, this is 60. This is 90. Then this one is going to be root of 3 over 2. Then this one is going to be root of 4 over 2. And root of 4, it just gives us 2. So this is 1. You see, right? So these ones of sine, I'm just going to write them here, but in the following direction. So I'm just going to start from 1. We know that we have the root of 3 over 2. Root of 2 over 2. We have the root of 2, we have 1 over 2. Then we have a 0. Cos of pi over 2, it's 0. Then if I divide them, I'm just going to get the one on top. This one is 1 over root of 3. Just going to get this over this for all. And then root of this one is 1. And then this one is root of 3. Then 1 divided by 0, it's infinite. So we can still do this. We can just confirm them, use a calculator, and then we confirm, right? So let's check. Now, we realize that tan of 1. What is tan of 1? If we come to tan and then we come to 1, we get pi over 4. You see, right? That's why this formula is correct. So we get pi over 4 for tan of 1. Now we say this. We say that we have the argument, we have r. It means that now we can express z in the form of r cos of theta plus I sine of theta in polar form. Our r is root of 2. Then we have cos of pi over 4 plus I sine of pi over 4. Already, I know what is cos of pi over 4. I can just come here. Then I check. Cos of pi over 4 is going to be root of 2 over 2. And also sine of pi over 4 is going to be root of 2 over 2. You see, right? Now it means that I can just get this. You can use a calculator, those who have a calculator, but myself here, I don't have a calculator, right? Root of 2 over 2 plus I. This one is also root of 2 over 2. So, root of 2 over 2. So those who have a calculator, please use a calculator and you tell me what do you get, right? Because I don't have a calculator here with me. So are you getting the same solution, those who have a calculator? So if you were trying to simplify this, let me show you that it's going to take us back to the same thing, right? Root of 2 times root of 2, this is 2 over 2 plus, also it's just going to give us this over this. If we check it, this will take us to 1 plus 1i. You see, right? So I was just confirming here. So this is the correct way. You can always confirm. So here we stop here for our polar form. You see, right? So if I try to confirm this, I realize that our polar form is correct. This is going to give me root of 2 over 2, root of 2 over 2. When I multiply back, I'm going to get this original question. You see, right? So this is correct. Now let's do another one and check. So our aim is to put this thing in this format. This is our polar form. So the second question that we had, I remember it was 1 minus I, right? So let me go to 1 minus I, it was B. 1 minus I. B was Z is equals to 1 minus I. And now what we have here is that Z has the form, or has the ordered pair, Our ordered pair is 1 and minus 1. And is in there, we check the quadrant. Our A, if I just draw this, our A is this one, our B is this one. Our A is positive here, and here we know that A is positive, you see, and then B is negative, and B is negative here. So it means that this thing is in the fourth quadrant. You see, right? It means that this thing is in the fourth quadrant. So we specify that this is in the fourth quadrant, and it's in the fourth quadrant. All right. After doing this, we now find our modulus of Z. This is just going to be the root of 1 squared plus minus 1 squared, which still remains the root of 2. And then from here, we find the angle. Remember, in the fourth quadrant, the formula for the angle remains the same. So this is just going to be B, which is minus 1 over 1, B over A, which this is going to be the arctan of minus 1. But if we check here, since I don't have a calculator, I don't have arctan of negative 1. I only have arctan 1. But here's the property that you should know now. I'm showing you this property. This is the same thing as having negative arctan of 1. So the negative will go outside. And we know what is arctan 1, right? You'll just use a calculator to check. So I don't have a calculator. Remember, I said that I'm just going to check with this table, right? Arctan 1 is a pi over 4. So I'm just going to have this thing to be negative pi over 4. You see, right? Now, since we have this, we can come now and say that we can express z in the form of r cos of theta plus I sine of theta. And guys, don't just say r when you're finding the modulus. Don't just say r without specifying that it's the modulus of z. R can be anything. That's why you must define it under modulus of z. You see, right? Always. So this is the root of 2. This is cos of negative pi over 4 plus I sine of negative pi over 4. Now, this is the solution that we get, right? But then we need to be sure, or we need to be certain that indeed this is the correct solution. So here's what we're going to be doing here from here. What we're going to do here, we're going to say that we're in the fourth quadrant. I don't want to leave my answers as cos of negative. You see, right? We're in the fourth quadrant. So we're going to check what is it that we can do for us to simplify this. So we're going to come and do this and say that in the fourth quadrant, let's go back to that thing. In the fourth quadrant, we say that cos is the one that is positive. So it means that the answer here is going to be like this. Since cos is positive there, it means that the answer of cos is going to be positive cos of pi over 4. You see, right? And the answer of sine, since we're in the fourth quadrant, is going to remain negative. You see, right? So this will be our solution. If you want to confirm this, we can even try to do this. Say this is the root of 2 times our cos pi over 4. Remember, it's a root of 2 over 2. We've checked that. Minus I times root of 2, this one. And sine of pi over 4, it's also root of 2 over 2. Then this one is going to give us 2 over 2 minus I 2 over 2. And this is just going to give us 1 minus I. We'll still get that solution, you see. So you'll still be correct to put it in this format. Your lecturer would see that you really understand what you're doing, right? But if you like that will be difficult, you can still leave it in this format. It's fine, as long as the negative angle is covered. So we see that this is indeed correct. So either way, if one would write this or this, they will still be correct. So C, that time we're given that we have z equals to minus 3i. So let me go confirm. I think we had that. Yeah, we had minus 3i, right? So when we have this, we are going to say that z has the pair, or the ordered pair, must specify that it's an ordered pair, minus 3 minus 3. And if they're both negative, guys, this is going to be in the third quadrant. So if we try to check, here it's negative, here it's negative. So this is the third quadrant. You see, right? So they're in the third quadrant if they're both negative. And is in the third quadrant. And third quadrant, that's where we are going to subtract pi, right? So first we find the modulus. This will just be minus 3 squared plus minus 3 squared. So this is just going to be 9 plus 9, which is 18. And 18 is 3 root of 2, right? Because if I'm in 18, I'm just going to say 9 times 2, and 9, the root of 9 this can be written like this, right? This is like 3 root of 2. So you can easily do that with a calculator. If you have a calculator, you can easily do that, right? Now we have this answer as the modulus. Now we come to our angle, arctan minus 3 over minus 3, and then here we see that we're going to subtract pi. This is the the third quadrant. Then this is going to be arctan. This is arctan 1 minus pi, and arctan 1, already this one I know it by heart, is pi over 4. Then I'm going to subtract pi. I'm going to get pi minus 4 pi over 4 is just going to be minus 3 pi over 4. If you have a calculator, guys, you can easily do that. Make sure that your calculator is in red. Change your calculator mode to red, right? Every time dealing with complex numbers, change it to red. Now, because we want to keep everything in pi form, if you write degrees, you are dead. It's over with you. Your answers are wrong. So z, if we write z in that format, z is equal to r cos of theta plus I sine of theta, and our r in this case is the root, it's 3 root of 2, and we have cos of negative 3 pi over 4 plus I sine of negative 3 pi over 4. And we remember that here we're in the third quadrant, and in the third quadrant, remember guys, here it's where only tan is positive. Here I say that sine is positive, here I say that cos is positive. So if only tan is positive, it means that these ones are going to be negative. You see, right? I can still simplify them to be like that. So I can come, let me leave that diagram there. I can come and say this is 3 root of 2 minus cos of 3 pi over 4 minus I sine of 3 pi over 4. You are still correct to write it like this. You say, right? Then we are good to go. Now we are going to say this. If I let's say now I come and say this is the solution, right? Let me go and check D first before. Let me check what is D. Yeah, D now we're given z is equal to I, and then is z equal to minus 1. So I'll try to recall that. Now we have z is equal to I. This one will be very important. It's going to, let me see, this is D. We're given z is equal to I. So here we're going to come and say that z has the ordered pair of z is 0, 1. Because this is I, remember, right now. So our A is 0, our B is 1. Remember, I said that if we have this now, our A, our B, if our B is greater than 0, it's going to be somewhere here where our A is 0. You see, right? And the angle here is what? It's pi over 2. So it means that, and we're going to say and. Now remember, this is not in any quadrant. It's not in first quadrant, second quadrant, third quadrant, or fourth quadrant. This is just in there. Now we're going to check this plane has it's divided into 2 sides, right? The positive part and the negative part. Also this one, positive part and negative part. And these parts are, this is the imaginary axis. This one is the real axis. You see, right? So we're going to come now and say this. Z is in this one. Z is in this one. This is the positive imaginary axis. You see, right now? Z is here. Then we can say that is in the positive imaginary axis. This is in the positive imaginary axis. Now, if it's in the positive imaginary axis, I'm going to get that r is equal to the modulus of z, which is equal to the root of 0 squared plus 1 squared, which the modulus is 1. And also theta, here theta is just going to be the arg of z, which is equal to pi over 2. You see, right? So even these ones here, I was supposed to say that this is the arg of z. Just forgot to put that. I just remembered now when I was putting that one, because I had no choice. So here also you say the arg of z. You must say theta equals to arg of z equals to arctan. Then you proceed, right? So it's pi over 2, right? Because it's in the positive imaginary axis. So it means that we can now express z in that format, plus I sine of theta. This is just going to be 1 cos of pi over 2 plus I sine of pi over 2. Then this is the solution. Yes, right? Now we come to D, to E. Here, remember, was z equals to minus 1, right? Z is equal to minus 1. So we're going to say that z has the ordered pair minus 1, 0, and it is in the, let's check. We have A, and here A is negative, so it means that it's here, and B is 0, you see, right now? So this is the negative, so it's not going to be the positive axis, you see, right now? So if we're going to be talking about the axis, we're going to say that this is in the negative real axis, because we're in the real axis now. So this is the negative real axis. It's in the negative real axis. If you've practiced this, it means that I'm just highlighting you right now. I'm just enlightening your knowledge based on this. So we first say r is equal to the modulus of z, which is just equal to minus 1 squared plus 0 squared, which is equal to 1. And then theta is going to be equal to the argument of z. Then the angle here is just going to be, remember, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So the angle is going to be pi because we are approaching pi from there. So it means that z can be written in that format: cos of theta plus I sine of theta. This is just going to be 1 cos of pi plus I sine of pi. And then we are good to go with this. Any question, guys? Because this will be the last part that we're doing on this topic. We're now moving to another part. Yes.
So what happened to that formula of tan uptan and then b over a? Doesn't apply when you have this kind of situation.
Yeah, that formula doesn't apply when our pair is in here. It's either here or here or here or here. You say right now?
Oh.
Yeah. Yeah, the formula does not apply here. That's why we should know these. We are forced to know these angles, that if it's here, these are the angles.
Oh. So another question. When am I supposed to subtract pi and when am I supposed to add pi?
You're going to add pi when you're in the second quadrant. Then when you're in the third quadrant, you subtract. I think the information is here. We can look at it somewhere.
Okay.
Let me just go to it first. I think it's just written down in the form of a table. You said, right? You just put
I see
it
that
there.
table, I see.
Yeah, you see in the second quadrant you add. You say, right, the second quadrant. Then the third quadrant you subtract. That's the only different thing. Then the rest I've put them in the form of a plane where a is 0, b is greater. We're talking about here. It's pi over 2. You say, right? So yeah, is it fine? So I think if it's fine, let me check. Yeah. So now next thing that we need to look at, let's look at these theorems that we're gonna be using in our De Moivre's theorems, right? We're gonna be, when we come to De Moivre's theorem, we're going to be using these. We'll be applying these theorems. So let's say, suppose that Z is equal to R cos this I sine, and W is equal to this. Let me just okay, but let's find, we can just go through them now here and then I'll explain, right? Now they say Z is equal to R1 cos of theta 1 plus I of sine 1, and W is equal to R2 cos of theta 1 plus I sine of theta 2. I think this one should be 2, right? Isn't this one supposed to be 2? This one. It is, right? It's not supposed to be 1. Let me check. Yeah, it's fine. We'll try to check as we go on, but I think that was supposed to be 2. So let's check. So now we'll say then, if we're going to multiply the two of them, we're going to multiply R with R, right? When we come to cos, we're going to add their angles. We're going to keep cos, we add their angles. Yeah, this is supposed to be 2. Then for the sine, we do the same thing. We keep the sine, we add the angles. So you'll see these properties are going to add up. And then likely someone also asked me today to say, would they penalize me if I was to not write them like this? Let's say complete them individual. Then I was like, not sure if you guys were able to consult with the lecturers, but I prefer that you write everything that you see in the guide. If they apply something in the guide, make sure that you use it, right? Now with this one of Z over W, this is like R1. Allow me to write this one because they didn't write it. Cos of theta 1 plus I sine of theta 1 all over R2 cos of theta 2 plus I sine of theta 2. So when you come to these ones, right, when we're dividing them like this, yeah, it was like this. I think the person computed this individually and then computed this individual. Then they got the same solution. But then they want us to apply this theorem, right, to say that this is going to remain the same, but with the cos, the one which is in the denominator, I'm just going to keep the cos and then subtract the one which is in the denominator. And with the sine, I'm going to do the same thing, keep the sine, then subtract the one which is in the denominator with the angles. You said right now. So that's what we'll be doing. We'll be using these properties to simplify our computations. It makes things easier, right? Sometimes if they can give you ZW and they say find the angle of ZW, it will be simple if you use this, right? Or the argument of ZW, Z over W, it will be simple. So now let's see. Now they say for all Z, W element of C, the modulus of function satisfies. Let me just see what else. Yeah, let's look at these guys. Last I think it's last year they brought a question similar to this. And then the question had like 6 marks, if I'm not mistaken. I don't know if it's last year or last of last year, I forgot that. Then This, if we're given that, they say that the absolute value of z will be greater or equal to 0, then they say equality holding if z is equal to 0. And which this is true, right? But I want us to prove the ones which are easy to prove. We're going to prove B. Not just easy to prove, but we can easily prove them by showing the computations, right? We're going to let z be equals to A plus BI and W be equals to C plus DI. Then we say the absolute value of Z W is equals to, now here's something that we should know, right? If I come here, I'm going to first say A plus BI, C plus DI, right? Put the modulus, and this is going to be inside. I'm going to have AC plus ADI plus BCI plus BDI squared. If we check this is just AC plus, then this one is AD plus BCI, then this is just going to be minus BD, because we know that I squared is equal to minus 1. So if we check here, this is just going to be AC minus BD plus AD plus BC I. And this is the same thing used in triangle inequality to say this is AC minus BD plus AD plus BC I, right? So, or we can still keep the I inside here to make things simple. So you can still try, someone would still try to do it in this way to say that this is what I would get, right? But someone would say that, okay, let me not do it in this way. It's going to complicate things. Let's say you tell yourself that, okay, it's going to complicate things. How about after getting to this point, you're saying this point, right? How about I apply the absolute values? We know that if it's the absolute values or it's the modulus of this plus this, is just going to be AC minus BD squared plus AD plus BC all squared. Obviously, this one would also work, right? If you try to work it out, it will also work. Then the other side, we're going to have the absolute value of Z, absolute value of W, which this is just going to be A plus BI, then this is C plus DI. Then I apply there. This is A squared plus B squared. This is C squared plus D squared. And here I'm going to get, if I put them together, I'm going to get A squared plus B squared. And then this is going to be C squared plus D all squared, right? So you could still try to, someone is texting. The person who was texting if you have anything to say, please make sure that you say it on the recording part, right? Because I think that on the, if you just text, I won't be able to see. Is there anyone saying anything, guys? Anyone who's saying anything? But if there's nothing, right? So this is what this is going to be. If we check, this is going to be A squared C squared. If I just multiply them together and check here, if I square this, I'm going to get A squared C squared, right? So if I try to do the same thing there, it's going to get A squared C squared. Then this was just going to be minus 2 AC BD. And then I was going to have plus BD all squared. So let's check. Then here I'm going to have plus Then if I multiply by the last one, it's going to be a squared d squared What are you saying, guys? Are you seeing let me check. Did I leave the class? Let me check.